Student. In this video I'm going to discuss about digital audio in the part of multimedia. So this will be the overall scenario of this video: introduction and characteristics of sound and digital audio systems, MIDI, audio video audio file formats, and using audio in multimedia applications. So basically, when we talk about the digital audio part in a multimedia, we need to know a little bit about the sound. So sound is simply waves of compressed air that move out from its source, similar to dropping a stone in the water. Your ears are sensitive to those compressed waves. Through your ear, that sensitive or waves of this sound will be understand, and these compressed waves, as the sound wave interact with your eardrum, the signal is sent to your brain, converting them to the sound that you recognize, that you understand. Two types of sounds can be there. We already know that in basics of physics, that is analog sound and digital sound. Analog is record and produce the signal. Digital signal is created to store as numerical data and easily reproduced and manipulated. But in case of analog sound, we cannot reproduce, or we cannot manipulate after it has been recorded. um, but digital sound can be reproduced and manipulated because those sound information are stored as a numerical values, so we can reproduce or manipulate digital sound. Here you can see sound is based on two things, that is energy and transport medium. The energy from a banging drum is converted into pressure that is transmitted by the air. There are two characteristics of sound waves. One is amplitude and second one is frequency. These two are very basic parameters of sound waves. Amplitude is the power of or we can say intensity of the sound. The louder the sound, the larger the amplitude. Frequency is the rate at which sound is measured. Frequency is the rate at which sound is measured. It is measured in cycle per second or hertz. Means how many cycles in a second sound of cycles or uh, sound of cycles are created per second can be measured as frequency, or we can say the unit is hertz. So these two parameters or characteristics are very basic characteristics for sound wave. The three class of sounds are like voices, musics, and sound effects. You can create more classes also, because these are just rudimentary classes. Voices is simple, whatever we talk, that is the voice. Music is created by music instruments. Sound effects also can be created using voices or musics or like that. So we cannot basically directly divide in three parts, three classes only. There might be other classes also, but to say, as we are dividing it in three, voice is defined as talking, not singing by human. Voice is defined as talking, not singing by human. It is does not have a pitch and a tone, but music can have rapid changes in tone and pitch. So the difference is here. You can see it is usually recorded and played in stereo. Sound effects can be voice or music, both can be. So it is vary in tone, pitch, and time. So digitizing the sound, how we can digitize the audio signal. Digitizing the sound means capturing the sound amplitude at a specific frequency. So we need to capture the sound in two values, that is amplitude and the specific frequency. The three characteristics for recording sound are frequency rate. We need to understand the frequency rate. We need to measure the amplitude measurement, and we need to know about sound channels. It can be mononeural or stereo. Okay. For multimedia computers, standard frequency rates includes this type of rates can be included, like 11.025 kilohertz, that is a frequency, 22.5 kilohertz, that is frequency rate, 44.1 kilohertz. Those are the frequency rates, standard frequency rates used in multimedia computers. Amplitude measurement is based on 8 bits. For if you use 1 byte or 8 bits for 256 levels of amplitude, and if you use 16 bits to measure or to store the amplitude, you can use 65,536 levels of amplitude. So here you can see in this diagram, microphone is attached to this digital mixing console, and this input is forwarded to digital system processor. Then it is forwarded to power amplifier. If you want to amplify the sound, then it will go to loudspeaker, the way to produce the voice sound. Calculating the audio's data size. How we can calculate the audio data size? There are three characteristics used to calculate audio file sizes, that is amplitude, sound channels, and frequency rate. C stands for number of channels. It might be mono channel, it might be stereo channel. In case of mono, that is 1 channel. In case of stereo, that is 2 channel. And S stands for sampling rate in hertz, that is cycle per second. T stands for a time or unit of time, that is second. B equal to bytes, 1 for 8 bits, 2 for 16 bits. So file size will be the multiplication of these four values, C into S into T into B. That will be the file size of the stored audio data. So you need to remember this one. It is very important to understand how we can create the or understand the file size of a audio data file. Digital audio is created when the characteristics of sound wave is present using number, a process referred to as digitizing. So digital audio is created when the characteristics of sound wave is represented using number. So we can represent the waves of sounds as a number, or we can say digitizing. We can digitize any sound. It might be microphone, it might be synthesizer. So we can digitize any sound. Digitized sound is called sample sound. So when we digitize the sound, or when we represent the sound waves as a number, that can be called as sample sound. For every nth fraction of a second, suppose if we take 1 by nth part of a second, a sample of a sound is taken and stored as a digital information in bits and bytes. So if we can divide a second in n part, then one part can be taken as a sample of sound and can be stored as digital information in bits and bytes. That is, we can take one part of n fractions of a second. The quality of digital recording depends on how often the samples are taken. Means if we divide the sample or divide that time in more number of fractions, then the quality will be more good. Higher the sampling rate, better is the quality of sound. That is the meaning of this line. Means when we divide, that number of fraction is higher, then obviously the sound information would be more minute. And then if we store them in as a digital information in bits or bytes, then the quality of the sound will be also increased. So sampling rates are normally used in multimedia, or we can say CD quality, that is 44.1 kilohertz, or it can be 22.0 kilohertz, or it can be 11.025 kilohertz. Larger the sample size, more accurate data will be described the recorded sound. The value of each sample is rounded off to the nearest integer called quantization. So we try to round off the each sample to the nearest neighbor integer, and this process is called quantization. Digital audio software support. What are the types of support we can get from a digital audio software? It can be like playback, or it can be like record, stop, fast forward, reverse, or rewind. This type of support can be created using a digital audio software. So there are also software available to edit the digital audio. We can trimming the clip, and also we can splice the clip, or we can also assemble or merge the clips. So there can be different type of software available in the internet. You can go through to use how can we use to edit the digital audio. Also there are also possibilities like volume adjustments and format conversions. Means we can convert the format of the file format of the digital audio, and this can be done also using different type of softwares. Also we can do using different types of software like resampling or downsampling. Means we can increase the number of sampling rate or we can decrease the sampling rate, and also we can fade in out the intensity of the sound. Equalization and time stretching. So we can equalize the sound or we can stretch the time. Digital signal processing and reverse sounds. We can process the digital signal, and also we can reverse the sounds using different softwares. So sound controls, in case of multimedia computes, usually have software that act as a control for computer sound playback and recording. This software includes selection of components like microphones, speakers, line in, line out, and also volume level, both monaural and stereo, recording input level, bass and treble controls. These controls are usually accessible for user from the operating system of the computer as well as from within the multimedia products themselves. So using the operating system or we can using the software, we can sense this type of components. MIDI, it means musical instrument digital interface. It is a communication standard developed in 1980s for electronic instruments and computers. It allows instruments from different manufacturers to communicate, but MIDI data is not digitized. It's only music data stored in numeric form. Digital audio is recorded whereas MIDI is a score. So try to differentiate this one. MIDI data or is not digitized. It's only a music data stored in numeric form. So MIDI is just a score. Device independent. MIDI value is device independent, and this file is a list of timestamp commands that are recordings of musical actions. Using MIDI, we can easily and quickly compose our own original score. The process of creating MIDI is quite different from digitizing a recorded audio. Digitized audio, or you can say bitmap image the MDI, then vector graphics. For digitized audio, we simply need to play the recording through a computer device that can digitally record the sound. Here you can see this is MIDI sound module. So, or you can see this is MIDI keyboard. This is MIDI in or MIDI out can be linked with USB MIDI cable to a PC. So to make a MIDI, we need notation software, we need sequencer software, we need synthesizer, or we need MIDI keyboard. So using these things, we can create this musical instrument digital interface. So there are advantages in case of MIDI files are more compact than audio files. MIDI is small, can be easily embedded into the web pages. MIDI sound source is high quality. This sounds better than audio files. MIDI data is completely editable. MIDI data can easily be converted to musical notations and vice versa. And there are different type of file formats available for audio that has been discussed in the last video. But you can also go through this material that I will share over the Google Meet. So there are different types of application available in using audio in multimedia. So determine the adding sound to multimedia project and following steps. Determine the file formats that are compatible with or you can say multimedia authoring software. Determine the sound playback capabilities that the end user system offers. decide the type of sound needed, decide where and when you want to use the digital audio or MIDI data, acquire source material by creating it from scratch or buying it. So these type of steps need to be followed up to create a multimedia project using sound. So edit the sounds to fit your project, test the sounds to be sure they are timed properly with the project's image. And also you need to consider about space consideration. Large amount of digital information is required for high quality sounds, which in turn requires large amount of space in your computer. If monaural sound is adequate, then one can cut the storage space by half or get double the playing time in the same memory space. So if you go stereo, then you will require more time, but if you go monaural or single channel, then you can cut the size of your sound file by half, or you can create double playing time in using the same memory space. With compression codecs, we can reduce the size to 1/8 the space, but there is loss of quality, and we can also downsample. So there are lots of encoding techniques available to compress the audio file, and that can be done to the 1/8 of the original space. But in that scenario, you will lose some quality of the original audio file, or you can also downsample, means you can decrease the sampling rate of the original file. So here formula is sampling rate into bit per sample divided by 8 is equal to byte per second. So sampling rate into sample size by 8 into second into 2 if stereo, that is the file size in KB. That is, we have discussed in previous slides that how can we found the size of the audio file. In case of audio recording, if we require CD quality recording, then digitize the sound at 44.1 kHz and a 60 bit to store at a sound studio. If we decide to do it ourselves, then we need to invest in basically acoustically treated room, high-end amplifiers, recording equipments, powerful microphones, like that. So digital audio tape systems provide a tape based 44.1 kHz and 16-bit record and record playback capability. DAT recordings are too accurate, precisely recording glitches, background noises, microphone pops, including coughs in the next room. So you can use this type of environment to create a good recording. A good editor can reduce the impact of these noises, but at the cost of time and money. Mobile phones also can record audio. USB flash memory recorders can be used to record, and recordings can be downloaded directly as digital files using USB cables or card readers. Audio CD is the method for digitally encoding the high quality stereo of the consumer CD market is an international standard, that is ISO 10149. Also known as Red Book audio standard. So you can go through this standard rules about creating the audio CDs, that is ISO 10149. Converter and burning software such as Toast and CD Creator from Roxio can translate digital files of RBF found on CD directly to the digital sound file formats like MP3 and WAV. In case of you want to know about sound for mobile, basically ringtones are normally associated with phones. Telephone system like pulsating at 90 volt, signal is sent to copper wire to energize the hammer like clangs a bell. But in the present system, mobile software takes the surge when come one call, depending on the programmed options, plays the user's choice of ringtone. Ringtones plays on very small speakers and often compete in a noisy environment. So that is one most very much good challenge to create a good ringtone. The other tones include answer tones, sing tones, true tones, real tones, video tones, and ringles. So that type of sound also can be created. So that this can be called as sound effects. So this is just the overview of digital audio applications, and also how it can be created and how we can measure the size of digital audio, and what are the software support we can get, and how it can be converted. These things has been discussed in this video. You will definitely understand this because this is simple one. If you have doubt also, please let me know. We'll try to resolve it over Google Meet. And next I'll try to go for more about digital sound through the encoding techniques, or how we can compress or decompress this digital sound. So that is more about technical things, but this video is only about basics about digital audio. So that's it in this video. Thank you.